Today we are starting Chapter 13. This is lecture number 1, and the entire chapter deals with gases. We are going to look at them qualitatively and compare them quantitatively. So that means there's going to be math. But the math is relatively straightforward, and you should not have difficulty with it. So when we discuss a gas, we talk about generally 4 variables: pressure, and pressure will be measured in the unit of a kilopascal. We can talk about volume, which is measured in liters. We can talk about temperature, which is measured in Kelvin, not Celsius. And we can talk about the number of moles, which has the abbreviation MOL. We are going to look at each of these variables and see how they affect gas pressure. So the first one is the amount of gas present. By adding a gas, you increase the number of gas particles. This will increase the number of collisions, which will increase the gas pressure. So here we're going to draw 2 cylinders. And each cylinder has a gauge. And in the first cylinder, we are going to put 5 gas particles. Remember, gases move in a straight line until they hit something. So we're going to show them rapidly moving around the container. These 5 particles, we will say, exert a pressure of 100 kilopascals. But what if we take that cylinder and we put in 10 particles? So 1, 2, 3, 8, 9, 10. And each of these particles traveling around all different directions, colliding with the side of the container, with each other. Because there are 10 particles, the gas gauge will read a higher pressure. In fact, when we double the number of particles, we will double the pressure. So there's a nice relationship between the amount of gas and the pressure. If you double the number of particles, you will double the pressure. So what if you triple the number of particles? Well, you will triple the pressure. The second factor which can affect the pressure on a gas is volume. The more we compress a gas, the greater its pressure will be. But we also have that same relationship. If you take half the volume, this time though, you will double the pressure. So it's an inverse relationship. If you double the volume, the gas particles can spread out more, they don't collide as often, so you will get half of the pressure. So if the pressure on a gas is halved, then its volume must have doubled. If the pressure on a gas is doubled, then its volume must have halved. So we're going to draw a cylinder. And inside the cylinder is a piston. We have gas particles at a volume of 1.0 liters. The piston is pushing down with a pressure of 100 kilopascals. So now what we're going to do is take that piston and double the pressure to 200 kilopascals. We still have 5 gas particles, but now the volume will equal only half of a liter. If we have a cylinder at 2 atmospheres of pressure, and there's different units for pressure, and the gas that is inside, doesn't matter how many particles there are, I'll make it 10. If those particles occupy a volume of 12.0 liters, and then we increase the volume by reducing the pressure to 1 atmosphere, then those 10 particles will occupy a volume of 24.0 liters. The third factor that affects pressure is temperature. Temperature is a measure of average kinetic energy. So the kinetic energy increases as the temperature increases. The particles move faster, so they hit the side of the container with more energy. Therefore, when the temperature is increased, there is an increase in pressure. But we have a relationship. If you double the Kelvin temperature, not Celsius, you will double the pressure. If you take half of the Kelvin temperature, you will get half of the pressure. Kelvin temperature is also related to the average kinetic energy, as we said above. So if the average kinetic energy doubles, it's because the Kelvin temperature doubles. If the pressure on a gas is doubled, the Kelvin temperature must have doubled. Notice this is a direct relationship. So as one goes up, the other goes up. If the pressure on a gas is halved, then the Kelvin temperature must have halved. So again, here's a cylinder. We're going to say it's at a temperature of 300 Kelvin, and it has a pressure of 100 kPa, and then there's some kind of gas inside. And now we take the cylinder and we heat it up. We double the temperature to 600 Kelvin, and that will double the pressure to 200 kilopascals. But notice, there are still only 6 particles in the container. It's just that now they're moving much faster. They have much more kinetic energy. This is why we don't throw aerosol cans into a fire, because we can build up the pressure so much inside of the aerosol that remains that we can actually explode the container. And that's it for today. So we'll see you in class tomorrow.